Those of you with very good memories will remember at the very start of the M102 course, Dwight covers scaling horizontally versus scaling vertically, and some of the trade-offs that are made to allow MongoDB to fit into that scaling out model in terms of features, and he does a good job of sort of relating where on that curve of features versus ability to scale MongoDB comes in and where some other things come in. So what we're going to do here is expand on that a little bit and talk about scaling out with shards and some of the practical considerations that you need to be aware of when you're doing that. The classic model for scaling with a vertical one, you start out with a server and you put your database on it, and you use this server until you run out of a resource, be it disk space, I/O, CPU, whatever that may be. What you used to do was you would just, well, buy a bigger server. You move your database over here, and your bigger server will handle 3x, 4x the load, whatever it happens to be, and your growth can continue unabated. This only works for so long. Eventually you run into the fact that you're on the biggest. So you've got the biggest host, the most I/O, with the most RAM, with the most CPU, whatever your limiting factor is. So when you put your database on this biggest host, you're kind of looking into the future and worrying that if you continue to grow, how on earth are you going to increase your capacity? This is the sort of the classic vertical scaling model. You're scaling it up by increasing the available resources on the same host. This does work for quite some time, and of course there are always newer, faster and better servers coming out, but if you're growing faster than they can improve your particular limiting factor, be it CPU, be it I/O, or anything else, then you're eventually going to run into this problem. There is another issue, of course. These things, the biggest and best in class, tend to be very, very expensive. So eventually you're going to run out of scalability. And the answer to that in modern times has been to scale horizontally. I mean, you see this all over the place. The idea is, let's use small commodity servers, 3 up to n, and we distribute our data in some way across all of them, and then we use our application to talk to the appropriate one, and thus we're able to scale this way. So if we need more capacity, we just add another box and keep expanding out here. That's a great idea in principle, but there are obviously going to be trade-offs. So this is going to be an intricate arrangement. You're going to have to either have all of these be completely interchangeable, or you're going to have to have some way of your app being smart enough to segregate between the two, know where data lives, etc., etc. That's where you get into partitioning and sharding solutions in the database world. So MongoDB implements automatic sharding for you. You don't have to split the data up manually, which is one of the options I've seen done in other cases where auto sharding is not actually available. I've seen people create their own in-house, in-application partitioning tables at the application level and scale out that way. So if you're willing to do the work and you think you can maintain it, then that's great. But if you're looking for a bit more of a cookie-cutter solution and you want the database to do the work for you, then you're going to want to look at those databases that allow you to scale horizontally. The solution in MongoDB is just simply referred to as sharding. When you shard your database, you do so in a sharded cluster. Sharded cluster is generally made up of, although it doesn't have to be, generally made up of replica sets, each replica set being an individual shard. So those are fronted by what we call a MongoS. Primary, secondary, secondary. Let's just say they're standard 3-node. And here's another MongoS here, just in case I think there's only one. This is shard 1, and this is shard 2. And your application talks to the MongoS. The MongoS is what's providing the coordination here. It has a map of where all your data lives. It knows how to route the queries appropriately. Functions very like a router, in fact. So the MongoS is what presents a single database to the application. The application doesn't have to be aware that sharding is going on here from its perspective. But when a query comes in, the MongoS determines which shards that particular query needs to go to. And let's just say it's only needs to go to shard 2. It will send it to shard 2. So a very, very basic view there of how sharding works. Now the practical considerations piece, and we'll get into exactly how all of this is managed and where the config servers come in and everything else shortly. So what are these practical considerations? Well, I would say that the key to a successful sharding strategy is planning. You need to know a couple of different things to do your planning. First of all, you need to know what your limits are. In other words, what is the constraining resource that requires you to add another shard? Now that can be many, many things. You may be sharding because of the fact that you want to keep all your data in RAM. Maybe an I/O limitation. You've got SSDs and you've got nice fast I/O, but eventually you ran out of capacity and you have to shard horizontally to add I/O capacity. So it depends, first of all, on what that limit is. And once you know that limit, then what you want to ensure is, as part of your planning process, that you never reach it. So once you've discovered the limit, make sure it's never reached. And what do I mean by that? You've moved to a sharding infrastructure so that you're able to add capacity by scaling horizontally. So let's just say you have 3 units like this. And this is shard 1, shard 2, and shard 3. Originally you were on shard 1 and you had a limitation in terms of the amount of data that you could keep in RAM on that single replica set. So what you did was you added shard 2. You doubled your capacity, and then you added shard 3, and now you've got 3 times your original capacity, and it actually is scaling nice and linearly here. So as you add it, you're basically adding roughly that amount of capacity again. The overheads seem to be pretty minimal. So when do you need to add shard 4? The general rule I would give you is that you should add capacity at roughly 80%. Now you may want to decrease this if you're growing extremely fast. I'm using this as a nice sort of general measurement. If you're going to double your traffic in 2 days and you know that it's going to take a day to add capacity, then you may want to scale out a bit quicker. But as a general rule, you're not going to see that type of crazy traffic growth. So add capacity at about 80%. You've still got a 20% buffer at that point. So you've still got some room to grow before things start to fall over or have problems. And once you've added your capacity at 80%, the next question you need to ask is, how much time does that buy you? If all that does is kick the can down the road a week, you haven't gained very much there, and maybe you should be adding more straight away to absorb future growth. If you're asking yourself these questions, if you're asking yourself, what are my limits? What am I at right now? How high can I go before I actually start to see problems? And how much do I need to add? You'll be able to come up with a successful sharding strategy. Keep this in mind. Keep asking yourself these questions. Figure out how to determine a measurement for your capacity at the moment. This might require load testing. It might require taking certain resources out to artificially increase the load to see where things start to actually suffer. But figure out what your capacity is. You can fudge it by 10-20% to give yourself a little bit of breathing room, but always add capacity early. Don't wait until you get to 100% utilization to do it. By that time, it can be a little bit too late.